Someone from the coding industry is well aware of the fact that there are hundreds of coding languages to learn. Budding aspirants are always curious to know which programming skills to learn. From the hundreds of choices available, it is important that you pick the right one. Some languages are more in demand than others and are used by major tech companies across the globe. Have a look at the top 10 programming languages that big tech companies use. Python. Python is an open source OOP language that is used in web and mobile development. This is one of the most preferred languages among data scientists and AI specialists. This language has libraries that make the creation of cross-platform mobile apps easier than ever. Python is simple, easy to learn, and highly productive. C and C++. This object-oriented language has a wide range of applications to serve, right from database management to operating systems and medical applications. Both C and C++ are static, general-purpose languages that are widely used in embedded systems. One of the biggest advantages of these languages is that the same code can be used on all major operating systems without errors. Java. Java is believed to be one of the most fast-performing object-oriented programming languages. The popularity of this language is so high that big tech companies such as Goldman Sachs, eBay, Google, etc. make use of it. Java's ability to scale effectively, compatibility with Android, and extensive framework base are a few of the many reasons why it is widely used. Javascript. JavaScript is both client-side and server-side technology that is widely used for interactive multimedia enhanced web pages. This programming language is known for its significant role in web development. With JavaScript, one can build interactive, fast, and responsive web interfaces. Additionally, the code is easy. Go. Go or Golang is an open-source programming language. Though it is relatively new, it has gained significant popularity over the course of time. It has its own set of testing tools and garbage collection that frees developers from the memory management burden. This programming language is capable of executing several processes concurrently. SQL, Structured Query Language. SQL is that one programming language that allows programmers to query and manipulate databases. This language stands for potential to locate and retrieve data from a database, as well as update, add, or remove records. It is highly functional and is considered to be one of the best languages for database management and business management. NoSQL, Non-Relational SQL. The main objective of NoSQL is to improve SQL's scalability while retaining the other language's ease of use. This programming language is highly efficient for a set of applications such as storing data in a hierarchical network or supporting large-scale cloud-based applications. Ruby. Ruby is that one programming language that supports multiple programming paradigms like object-oriented, imperative, and functional, and supports automatic memory management and dynamic type systems. Ruby is widely used in backend servers and databases. The syntax is quite easy, thus making it easy for beginners to understand as well. C#. C#, being able to support a range of object-oriented programming principles, has grabbed attention from everywhere across. This is why major tech companies use this programming language. C# is ideally suited for apps for Windows, Android, and iOS and is utilized on the back end of several well-known websites. R, an open source language, is a variant of the S programming language. The applications of this programming language include linear and nonlinear modeling, computation, testing, visualization, and analysis, to name a few. The proliferation of low-code and no-code applications are changing the landscape for software. In the past decade, growth in these areas has empowered employees to generate solutions at the speed of a digital world, regardless of their technical background. This raises several questions. What kind of programmers do businesses really need? Should they still rely on programmers formally trained at four-year universities, what you might call white-collar programmers? Or instead, are blue-collar programmers with self-taught skills or those who learned from a bootcamp more valuable? What will get organization the right mix of programming skills? The short answer is that all programmers can be of great value. In general, blue-collar programmers, after all, connect things within the competing environment, while white-collar programmers create the things that are connected. The essence of low-code is that it allows more people to connect things and use their creativity to become more productive. But it doesn't eliminate the need for professional programming and tools at its foundation. At their core, low-code and no-code are about democratization. They allow people without technical skills to work creatively in ways that essentially make everyone a programmer. A parallel from an earlier computing generation is the Excel spreadsheet, which lets people with no programming background perform computational tasks and eventually work their way up from simple formatting to full-fledged programming. But at some point, polished programming skills are still necessary. No matter how easy no-coder or low-code can make some of those elements. In the breakneck pace of cloud-based computing environments, with new services constantly being developed and deployed to the edge, it is worth considering the distinction between the white and blue-collar programmers and what kinds of education are appropriate for each. A career as a programmer can seem intimidating for onlookers. This is particularly true when these jobs involve complex languages such as C++ and Java, which are often used in large projects that can take years to develop and involve millions of lines of code. Some of that is still true, but the evolution of programming over the years toward languages that require less code, such as Python, and to domain-specific languages, DSLs, has also started to lower the barrier to entry for programming. It is true that you have never needed a 4-year computer science degree to be a programmer. In fact, many that have dropped out of college or never attended at all have made significant contributions to the industry. However, universities do provide a foundation in theory and algorithms that have always served programmers well and enable them to branch out into new areas such as artificial intelligence or other disciplines such as bioinformatics. Coding bootcamps, for their part, can provide intensive training on DSLs or frameworks like Rails or React.js that can benefit companies' plans, giving blue-collar programmers the practical skills that white-collar programmers may not have. They also attract career-changing attendees with 4-year degrees in other subjects, including the humanities and the sciences, which brings badly needed new ways of thinking into the profession. While each method is valid, both 4-year institutions and bootcamps also have their shortcomings. Universities delve deep into software development theory but often don't emphasize critical aspects of doing the job, such as teamwork, testing, and agile processes. Nor do they focus much on core areas of businesses today, like cloud computing. Bootcamps, by targeting specific areas and emerging technologies and languages, can help people get internships or entry-level jobs, but don't provide a broader theoretical knowledge of programming. and they can be hit or miss, with some of them using sketchy practices for payments and job placements. The inherent weakness in both white and blue-collar training can be addressed through apprenticeship and internships, but only to a point. The question remains, who will train low-code programmers on modern development and coding practices? A lot of companies throw around terms like Agile and CI/CD, but they are often just new labels on old, inefficient practices. Companies will need white-collar programmers to bring blue-collar programmers up to speed.